Alright, in today's video, we are going to perform an experimental setup of a GPF cluster. The purpose of this video is purely for learning purpose, and so we can set up an environment to learn some advanced DB2 knowledge, such as pure scale. This is supposed to be the third video, and previously we had one for the installation of DB2 with pure scale features. That is only the software install. And also we have a video called iSCSI target. So that is going to provide us the shared storage for the GPS cluster or the to like a DB2 pure scale cluster to work. Okay. So here's our demo system. We totally have 5 servers. One server, it is hostname DC1. OS is Windows Server 2025 and IP address. So this server is going to provide the shared storage iSCSI disk. So we have 4 Linux servers. They are Red Hat Linux server, Red Hat 9.5, and with the DB211 software installed. So the iSCSI disk in my case, it's /dev/sdb that is provided by the DC1. So the host name, just for demo purpose, its respective name is CF1, M1, M2, and CF2 means this is a caching facility server. This is also caching facility. This is the member, cluster member 1, member 2. And one thing I would like to mention is the kernel, because the OS is 9.5, and the server was built previously 9.4. After I upgrade to 9.5, they got a new kernel, but the new kernel doesn't seem to work with the DB2 12.1. So I have to boot into the old kernel. That is the kernel come with 9.4. Okay, so this is the kernel I'm using. Hopefully in the future, like DB2 fixback, they will fix this issue. So, and all right, so let's get started. And so everything command we run gonna run as a root user, and some prep work is already done. Okay, so first we assume the DB2 install, like one of the video using this command, DB2 install, and the pure scale feature, it's already installed. Let's take an example. And this is one example. You see this is one of the server. This is the command. And then this is the outcome. At the end, you will see the execution was successful. Another server is also have the similar thing. So all these 4 server, CF1, M1, and M2, and the CF2, the DB2 software is already installed. If I do a DB2LS, you can, we're gonna take a minute. For some reason, the DB2LS return you will see confirm. Okay, so now let's look at the networking. So because we are using the local host, so everything is going to be in the let me exit just from beginning. So I'm going to use this CH1 CF1 as from there I'm going to execute all the command. Okay, so let's log on. So after log on, this is the host name. This is the operating system. This is the current kernel and IP address. Okay, so let's get to the HC host. So this is the host. It's basically it's his IP address, the fully qualified name, and this is short name. Okay, and in the domain environment, in the corporate environment, this is be the your like a domain name and with host name. Okay, so like for example, if you have host name minus s, this is host name minus s, this is the short name, right? Host name. If we find a long name, that is not long name, fully qualified domain name, let's give us the name plus the domain. Okay, so in my case, this is an arbitrary domain. All right, so let's continue. So the second thing we need to set the SS password between the host for the root user. So it's pretty straightforward. We already did. So it's for the Linux user, this is the basic setup. So basically, you just communicate the key between hosts. Okay, so let's confirm. So first, let me confirm. Let's see host name. So I'm on the CF1, right? I'm able to run against let's see M1 and return remote name. So it's working, right? So I can also do the M2 and make sure from CF1 we can run against another 3 server and also this 3. Okay, so this is going to be the CF2, right? So we also want to use the fully qualified domain, make sure the fully qualified domain also needed. So if we do the similar thing, just check. Okay, it's called the demo.db. One more. Let's see, demo.db host name. Okay. Okay, so all right, so let's check as well. You can see same thing. So if we on another server, we should do the same thing. Make sure this is working. So for example, I'm on M1, right? So on M1, then we will be able to SSH to another 3. So that's going to be CF1, right? So we'll get make sure those things. I will skip the rest of so just use these 2 as example. And so to demo the SSH, it's being established. Okay. All right, so let's continue. So SSH, make sure the SSH is done. So the third is the SCSI. So you can see this is provided for the DC1. So we have the SCSI is mounted to attach to the Linux server. So we can run ls BLK, right? So you can see this is the disk, okay? Ls BLK, ls BLK, and BLK. You see all these faults. This disk, raw disk, was attached to this fault server. In the real world, many times we may just use SSH for convenience. Sometimes when we we can run remote as well. Okay. So I think at this moment, the previous the prerequisite is already satisfied. So now we're gonna do the GPF cluster. Okay, this can be done from any server, but we're gonna use CF1 in this case. In IBA term called IIL, initialize the install host RH, not something called initialized install host. So that is when this command was initiated. You can theoretically we can use any of this, but we just use CF1 for this case. Okay. So all the GPFS related cluster, it is in this location. So let's take a look. So if you see, look at this location. So this is all the GPS cluster. In order to let's see if we just do a mm. Let's see. You can see that's like 200 command, something like that. Okay, so because we don't want the whole path, so for convenience we just export this one, or you can put this into the etc etc profile or your bash profile, bash rc. All right, so we have all the commands. So the first command is called cluster. So it's called basically the command is it's very simple and intuitive. It's very like the Linux command. And the reason we're doing this because we want to separate the file system creation with the DB2 cluster, like the pacemaker cluster setup. Okay, so we're going to do this manual and also mainly for learning purpose. Okay, so this is the MM cluster. So you can use help page or man page. So you basically can see what does it mean. Minus n is the node. Minus c is the cluster name, and minus nu it is domain name. So simply we just copy paste. We're gonna create a cluster called the demo cluster with these 4 nodes. The node description is quorum and manager. Okay. So we're gonna run this. So the reason I pick a quorum dash manager is just by default. Okay, so that is the if we instead of use the cluster, we use the db2 utility like a db2cm. They will default to quorum manager. All right, let's continue. The cluster is created. We can just they also you see that's called accepted the license. Okay, so we can accept the license. We can look at this cluster after the creation. You see ML list cluster. It is a very simple command. So you can see it says we have 4 node CM1, CF1, M1, M2, IP, and assigned the admin node and the designation, also the cluster name. You see we specify the demo cluster, so they just give this pin after this domain name. Okay, and also the domain. This is GPS UID domain, so it's the same as the cluster name because we didn't specify the separate domain name for this cluster. Okay, just be the same. All right, let's continue. So now we're gonna accept the license. So we basically accept all the node. Okay. So accept the license. So let's continue. At this moment, we basically can start the cluster, the GPFS cluster. Okay, so let's do the startup. Startup. You see, the command is very intuitive. It's very easy to remember. So then after that, we can check the state of these clusters. It's called state. And this minus A, it is for all nodes. Okay, so if we do you can see it. So it's arbitrating. So let's start all the node. Okay, so I'm going to start minus A. Okay. Yeah, they said for CF1 it is already active. So now let's get to the state minus A as well. So you can see for all nodes. Right now it is it's gonna take a little bit of time to from down to arbitrating and then to the active. So this is the GPFS state. Okay, let's try second time. Right now it is all arbitrating. So let's give it one more try to see if it is ready yet. Still arbitrating, I think, because the server is very slow, so they're gonna take a little bit time to become active. All right, let's try. Okay, you see all active. It takes a little bit time to become active. Okay, so let's continue. And okay, we can also run the get state minus AL, so we can get some more detail. Okay, so you're basically telling the number of columns, nodes, number of nodes up, total nodes, states, and the remark. Okay, and so the next step is we're going to create the NSD. The NSD is called Network Shared Disk. It's basically, and GPFS is going to use this to create the shared file system. So we're going to use this text just to create the NSD. Okay, so let me run this command. So basically, they just put the content into this this file. Okay, so I put it into the home directory. I need a. Okay, so if we get the NSD is identical this 4-line text. Okay, so now we're gonna create using the mmcrnsd. So we're gonna use this. The capital minus F means the file. Okay, so we're gonna read this file and create the NSD. Before we do that, let's do ls NSD. Right now there's nothing, right? So there's no disk, so we're gonna create. So you see it's gonna say create the /dev sdb. That is the raw disk, and after that and we run this, you can see the network shared. It's right now it's a free disk. Okay. If we do this, you can see on the disk level, it's already created a partition. So the next one is going to create the file system. So file system, this is the syntax we're using. So it's very simple. So we're gonna call this file system called demo GPFS, and we're gonna read from this file we created, the demo NSD, and we're gonna mount to this directory. Okay, so if we do ls, right now we don't have this directory. After create a file system, we will mount. Okay, so let's copy this one. So it says okay, so it's gonna take a little bit time. Let me pause the video. Okay. All right, and it's completed. It said complete the creation of the file, this file system. Okay, so now let's see. There is. Let's see. Yeah, you see this directory is already created. If we do cat at the FS tab, you can also see this is being added to the FS tab. Okay. All right. So let's just now we're gonna I think there's command called msfs as well. The list list all. And so this is the file system. Okay, so now we're gonna mount. Okay, so it's similar m mount. So the file system in our case it is this one. So we're gonna mount it to all servers. Okay, -a. -a behind this. So before we mount this, let's take a look at on each server. Right now, we don't see anything being mounted. Okay, after mounting, we will see. Okay, so let me just mount this file system. And okay, so it's mounted. So if we do a df-h, you can see this is this file system was mounted here. If we do ls, in our case, here is the file system. It's mounted. Okay. All right. So then this file system we're going to use for the pure sub creation, the shadow location. Okay. So if you do if we go to another server, we can see this as well. You see similar thing, right? So and go to another one. Let's see. Okay, go to another one. All right, so and you can we can also use remote. See m1 ef -h, right? And grep dbt, and yeah, you can see the similar thing. So let's see if we do m2, we also get this one. Okay, so let me do a df-h one more time. Now it's normal. So it's used 1.7 gig 29. It is free. Okay, so you see earlier it says 13 gig 29 it's used. It's incorrect. Now it's gradually it's everything is back to normal. All right, so at this moment, let's see. Oh yeah, we created. It's mounted, and if we do a, let's take a look at net stat. It's the all right. So at least we see one thing, right? So the MMFSD is running. So they listen to 1191. So that is the FMSD for the pure, not pure, so pure GPF cluster. Okay. So next video we're gonna use this shared location and create our pure scale instance. Okay. So all right. So that's for today.